let's start today's video. Today I am gonna discuss some important topics of particle physics 1 for a quick revision. Okay, let's start. First, I will classify the particles in terms of interaction. Okay, particles in terms of interaction. The pen tab I am using, I am not that much familiar, so you can little adjust. Hadrons. Hadrons are further classified as mesons and baryons. Another branch is known as leptons. Let me give you some examples of leptons: electron, gamma electron, muon, gamma muon, tauon, gamma tauon, which are baryons and mesons. It will be clear after some diagrams. So let me draw some diagrams. First, I want to introduce baryon octet. In this axis will be strangeness. Strangeness is a special quantum number, and along the x-axis I will take I3, third component of isospin. These special quantum numbers will get clear after some time to you. Okay. By bar I will point the particles here: proton, neutron, sigma particles, cascade, okay. So along this x-axis line, the value of strangeness will be, let me mention here, is denoting the strangeness 0, and along this horizontal line the value of strangeness will be -1, and along this it will be -2. Okay, here I3 will be plus half, here minus half, here -1. For it will be 0, and for this it will be 1. Okay, and here plus half, and here minus half. This is the IV values. So these are the baryons. Let's go to another picture. I will introduce more baryons to you. Baryon Decuplet. Let me change the thickness. Okay, sorry. Again, I will take along x axis I3 and along y strangeness. Okay, let me use some dots to put the particles. Okay, let me connect this. Here will be delta plus plus, delta plus, delta 0, delta minus. Here will be sigma minus, sigma 0, sigma plus. Here will be cascade minus, cascade 0, and here omega minus. So now I will write the strangeness values for this horizontal line. The strangeness will be 0. For this it will be -1, it will be -2, and it will be -3. Okay, and here the I3 value will be 3 by 2, half, and for this it will be minus half, and for this it will be minus 3 by 2, and for this cascade, for this sigma minus it will be sorry, oh sorry. Okay, it will be -1, it will be 0, it will be plus 1. These are the I3 values. And for this, I3 will be half, minus half, and for this it will be 0. Okay, let me introduce the Meson Nonet to you, and you can see these all are baryons. So the Meson Nonet. Okay, let me write the mesons K0, K plus pi minus eta pi 0 pi plus K0 bar K minus. There won't be any particle. Okay, so again I have taken along y the strangeness and along x I3. Now I will write again the strangeness values of them. For this row it will be plus 1, for this it will be 0, and for this it will be minus 1. Okay, let me write the I3 values. It will be plus half, it will be minus half, it will be minus 1, it will be 0, it will be plus 1, it will be again half, and for this it will be minus half. Okay, let's learn about some conservation laws. So conservation laws. Depending on the conservation laws and their violation, we can classify the interactions also. Let's make a small chart so that you can easily understand it. First column, I will take strong interaction, second EM, and last one weak interaction. First, energy and momentum. This will be conserved in all of three. Next, angular momentum, this will be also conserved in all of three. Charge, lepton number, baryon number, if any of these get valid in a given reaction, then the reaction is not allowed. So these laws are essential, and for these laws reaction will be allowed if these are obeyed. Okay, so again I am making the columns. Now I will take these special quantum numbers. I means the isospin. Okay, and this is the third component of isospin, and S is strangeness. So for strong reaction, all of them will be conserved. For EM case, I won't be conserved, but rest of the two will be conserved. For weak, three of those won't be conserved. So depending on the conservation of I3 and S, you can understand the nature of the interaction, whether it is strong or EM or weak interaction. Okay, now I want to little discuss about the quantum numbers that I have mentioned just before, like lepton number. The lepton number will be plus 1 for leptons and minus 1 for anti-leptons, 0 for others. I have just given examples of lepton just a moment before. Let me show you again. Oh, sorry. So these were my leptons. Okay. Next, the baryon number. Baryons I have already introduced using those diagrams. Okay, baryon number will be plus 1 for baryons, minus 1 for anti-baryons, and 0 for others. Okay, next isospin. It is denoted using this capital I, and if we know the isospin quantum number, we can find number of multiplet which will be equal to 2i plus 1. Suppose let I give you a example. For this pi family, I is 1. Okay, so how many multiplets will be there? 3, which are pi minus, pi 0, pi plus. Okay, next I3, which is the third component of I. I3 can take values from minus I to plus I. Okay, good. Let me give a example of a reaction so that you can easily classify the nature of the interaction. Let me write pi 0 plus p pi plus n. Okay, so this is a valid and allowed reaction. Okay, I want to understand the nature of it. So what I will do, I first check the I quantum number of both sides, I then I3 and then S. You can clearly see there is no strange particle. Okay, so strangeness is conserved in both sides. As I have, sorry, just given you a small interaction of the strange particles. Look, these are the particles which have strange number not equal to 0, but neutron, these pi particles have strangeness 0, and if you look here, neutron and proton also have strangeness 0. Okay, so what you have in this given reactions, there is no strange particle, so strangeness is conserved in both sides. Okay, now for pi 0, I value is 1, and for proton it is half, and similarly pi plus also it is 1, and for this it is half. So you can clearly see both sides it is just the equal. Okay, now for pi 0, I3 will be 0, and proton I3 would be plus half, and for pi plus it will be plus 1, and for neutron it is minus 1. So you can clearly see that for both sides the value is half. So all of the three I, I3 and H are conserved here. So what I can write, it is a strong interaction. Okay, so this was a small and quick revision sort of for conservation laws. Thank you. For details you can read Griffiths. I guess it is chapter 5. Okay, thank you.